Hello everyone, I am Anis. My thesis is in collaboration with Open Company. My subject consists in choosing the best combination of cloud services according to the need expressed by architects. To achieve this, we go through several steps. In this presentation, we will address the step of identifying the key elements that are used to compare services and their relationships. The outline of my presentation will be as follows. First, I will present the problem of identifying key comparison elements and their relationships for the selection of cloud services. Then, I will present the proposed method and the results. Finally, I will present the future works. Today, Open Company has many applications that are deployed in the cloud. These applications are built on the basis of composition of services, like MySQL database and queue services and other services. Architects no longer try to implement their services themselves, but consume them while leaving the operation burden to service providers. Providers are expected to maintain and secure the service as much as possible. We witness the emergence of hundreds of cloud providers that offer several types of services, such as messaging services, storage services, queuing services, etc. These services are presented as plans that are described with different configurations. A cloud service is described by both functional and non-functional requirements. The functional requirements specify the task that the service must perform. For example, for storage services, the functional requirement is storage capacity. The non-functional requirements specify the quality that the service must possess, such as safety, availability, reliability, security, etc. As this figure shows, there are several cloud providers, such as Google, Amazon, Azure, IBM, that offer a wide range of services that are similar in functional requirements and different in non-functional requirements. This is an example of application architecture. It could be more complex. This application is composed of three microservices. Each microservice relies on a separate database system. We want to deploy our application without installing servers, just consuming services. The question raised by the service selection issue is how to choose for each microservice the SQL services that best suit its needs. In order to select cloud service plan for an application, both functional and non-functional service requirements must be identified. This is a complicated task because heterogeneity is the rule, business models are very diverse, plans are described from the supplier's point of view, provider point of view, and not from the consumer's point of view. Service plans are described by a variety of NFA. These NFA differ from supplier to unknown, are incomplete or are identical with different designation. The service description may be incomplete. For example, the provider CTUS data does not provide important information about the service, like does the service support encryption of data at rest? Does the service provide backup and single tenants? Identical attribute declared in different ways. The provider declared the same attribute under different designation. For example, backup retention is reported as BG backup pre-retained for PostgreSQL, and backup retention for GRWSDB MySQL. Plan described by different attributes. For example, the provider of GRWSDB MySQL declared that it uses single tenant, while PostgreSQL does not. The plan are described with different attributes for the same service provider. For example, the Hobby Basic plan, which costs €9, does not offer or provide encryption at rest and high availability, whereas the Private 4 plan, which costs €15,000, offer high availability and encryption at rest. Now we will discuss of proposed method. To select cloud services, our method involves three steps. First, identify the key elements of the comparison and the relationships. Assess NFA and attribute NFA. Compute the trade-off between price and NFA. In this presentation, we addressed the first part of our study, which consists of identifying the key elements of the comparison and their relationships. To identify the comparison key elements and their relationships, we first discuss with architects to understand their service requirements. Next, we identify the NFA and NFL that answer architects' questions and their relationships from the service provider plan. Then, since performance is a specific NFL, the only way to determine it is to use benchmark. We identify the NFA that influence performance from benchmark study. Finally, we conduct an empirical study to ensure that the list of NFA and NFL is complete for the service selection process. In order to select the appropriate service plan for a specific application, we need to understand the architect's requirements. We organized an interview with some architects to clarify their minimum requirements and expectations from the different services. We asked architects about their overall service requirements through open-ended questions, like what question should they answer to choose the best plan from cloud service providers for their application. From this interview, we have compiled a list of questions that architects consider when choosing cloud services. Regarding availability, architects raised the following questions. What are the regions available for service? Do service plan provide replication and failover support? How is the service deployed? Etc. From the service plan, we have identified the dimensions of service evaluation. Capacity attribute provide information about the performance and capacity of the service. Functional attribute provide information about the attribute functional coverage of the service. The service attribute provide information about the service level associated with the plan, such as the availability of 24-hour support or certain SLA. Technical attributes are all other attributes that describe how the service is deployed or operated. For the capacity attribute, we find storage capacity, IOPS, number of connection, request per month, throughput, etc. For the functional attribute, we find monitoring, support, protocol, administration, functionality, etc. For the service attribute, we find SLA on availability, SLA on support, SLA on monitoring, etc. Technical attributes give a description of operational condition of the service and have an impact on different elements. The technical attributes of the database are RAM, backup, rollback, single tenant, etc. and other. Impact of technical attribute on non-functional requirement is a difficult task because it depends on several parameters. Among these parameters is the type of application that architects want to deploy. At this point, we can only indicate whether the technical attribute has a positive or negative influence on the NF. For example, replication has a positive influence on availability and security and a negative influence on performance. We present in this part an example of a use case on relational database. We present the issue raised by this study, grouped according to their influence on non-functional requirements. Regarding availability, architect raised the following questions. What are the regions available for service? Are they adequate in terms of legal and regulatory requirements? Do architect plan provide replication and failover support, etc.? Cloud SQL services run on provider's virtual machine. This virtual machine has a direct impact on the SQL services that run on them. Therefore, NFA that influence the performance of virtual machine also influence the performance of SQL services. So, we reviewed previous work, that is conducting a large literature review to collect and codify existing research on the predictability on performance. We have concluded that the following attributes are relevant to assess the performance of cloud SQL services that affect service performance: the CPU model, the hardware heterogeneity, and the tenancy model, etc. To validate our methodology, we define the attribute of the cloud SQL database services. Given the difficulty of determining the level of influence of the NFA on NFR, we present in this table the technical attribute with the estimate positive, neutral, or negative impact of NFA. At this stage, this is all what we can say about this impact. From our empirical study, we have collected several responses. For example, to the questions, why did you choose the high availability option for your service when it costs about twice as much as a regular instance? Architect A1, A2, A5, and A6 replied, the MySQL service is a business service in our application. It should be very available. This is the critical part of the application. A failure of this service will cause the failure of the entire application. A failover is necessary to maintain the services available when the instance is blocked. It has happened that the primary instance is blocked and that a restart of the instance take up to 30 minutes. To avoid this downtime time, we have opted for the high availability option. An architect of A4, A3, and A7 replied, a complete failure of a zone is probably very rare. So high availability is an important option, but not so important as to be indispensable. We asked several questions about selection of cloud SQL database services and ensure that the list of NFA previously collected was relevant to our study. We believe that our work is a successful first attempt to provide the basis for a solid decision-making process that is totally lacking today. In our future work, we will use the results of this study to evaluate cloud services and their composition. First of all, the relative importance of the attribute and NFA should be determined according to the type of application, and the accuracy of the results should be validated by the architect. Then, based on the previous results, a methodology will be proposed to evaluate the cloud services and their composition. The work presented in this paper is the first step toward the guided selection of a set of service meeting the requirements of a complete architecture. Thank you.